Hello and welcome to today's class. So in today's class, I'm going to handle a very important topic. Most students tend to shy from this topic, and that is completing square method. All right, that is usually used in solving quadratic equations. Okay, so Uh, I'm just going to quickly introduce you to how to use completing square method to solve quadratic equations. Right, so in our previous class, I handled the concept of quadratic identities, all right? So basically what that class entailed or introduced us to was the fact that quadratic equations and expressions uh, sometimes also are squares, of linear form square roots. All right, so a quadratic expression can actually be and can actually form what we call a perfect square at certain points. Okay, so we gave an example and we said, for example, if you're having let's say x minus a squared, then you realize that its square will look something like x squared, all right, minus 2ax, all right, minus a squared. So that was the general formula for a situation, let's say, where you have x minus a and you're trying to square it. And so you notice that from here we can actually find the square root of this quadratic expression right here. And that, okay, if this is the square, then its square root would actually be its square root will actually be x minus a. All right, the square root will be x minus a. And so how do you do that? Basically just find the square of the left hand side and the right hand side. All right, so when you do that, then you notice that the square of x minus a will basically be x. All right, x minus a right there. So we'll do away with the square sign right there. So this is just an illustration of what I mean when I say that quadratic expressions actually can form squares. And maybe another example we gave of a quadratic identity in that class was x plus a. And so if you decide to square x plus a, we said that you would get the square of x plus a as x squared plus 2ax plus plus a squared. So basically it's x squared, all right, plus x times a times 2, so giving us 2ax. So x times a giving us xa, or ax times 2 giving us 2ax, all right, plus a squared. And so if this here is the square, if this here is the square of x plus a, then you realize that its square root will actually be what? X plus a. That will be the square root. The square root will be x plus a. So one thing that is coming out as obvious is that quadratic expressions can actually form what we call perfect squares. Okay, that is what is coming out as an obvious fact, that quadratic expressions can actually form what we call perfect squares. And that if they can form perfect squares, all right, if they can form perfect squares, then we can also find their square roots, and then we can find the square roots of these perfect squares. And so the concept of completing square method is basically built on this particular fact, that actually certain quadratic expressions do form perfect squares. And so with that concept in mind, we can always find their square roots and end up solving quadratic equations. Now, why don't I maybe illustrate this concept further to you? Then it makes more sense, than it is already doing. So at the moment, we are in agreement that actually quadratic expressions do form squares, okay? Quadratic expressions do form squares, and that if they do form squares, then indeed we can also find the square roots of these quadratic expressions. Now, the general formula for any quadratic expression is ax squared plus bx plus c. So this is the general formula for any quadratic expression. It takes the form ax squared plus bx plus c. Now, what if we wanted to find out if the equation we have in mind actually forms a square? All right. So this is the general formula for any quadratic equation: ax plus bx plus c. All right. So for it to actually be a perfect square, all right, for it to actually be a perfect square, it will take a different form. All right. For it to be a perfect square, this quadratic expression will take a different form. All right. So these are the requirements that it will have to meet. First of all, a must be equal to 1. All right. A must be equal to 1. So you always want to find out that a is equal to 1. All right. For us to find out if it's a perfect square. Then 2. C will always be b all over 2 squared. All right. So the value of c will always be the value of b divided by 2, and then you square it. All right. So basically, for us to form a perfect square, all right, of a quadratic expression, then we need it in the format x squared, where a is equal to 1, all right, plus bx, all right, plus, now remember, c should be equal to b all over 2 squared, plus, so instead of writing c, all right, we will have it written as b all over 2 squared. So anytime we have this particular form, of quadratic expression, then we describe it as a perfect square. All right, we describe it as a perfect square. And so note, as I said earlier, if it forms a square, then it should be able to form what? A square root. If it forms a square, then it should be able to form a square root. So why don't we go ahead and try and express this in terms of its square root? All right. So what would be actually the square root of this particular expression here? So for us to find out the square root of this expression, it's easy. So basically, we're going to take the first term. All right, so we're going to have it as x, all right, without the power, all right, plus, because we are having our b as plus there. So b can always be positive or negative. So you always want to check on the power on the sign of b there. So if b is negative, we'll have it as negative. If b is positive, then we'll have it as positive. So we'll have it as x. We just take the x plus, now b all over 2. So the b all over 2 we're talking about is the one that we have used to express the value of c here. So if we have it as x plus b all over 2 and all of this squared, then note, if you are to expand this, you will come back to this. If you're to expand x plus b all over 2, you'd come back to this. So with this concept in mind, we then realize that the square root of this particular perfect square of a quadratic expression will be, when you find the square root of this, will be actually x plus b all over 2. All right, x plus b all over all over 2. It's the same way when you have the square the square of, if you have 9, yeah, we know that 9 is a perfect square, so its square root basically will be 3. All right. So that is what we are having here. So so of course you realize that of course this is just another unrelated example. If I say I speak of 3 squared, okay, then if I wanted to find its square root, note that this will just be 3. So that is the same concept we're using here. So because we're saying that this root and this 2 basically will simplify each other out, and so we'll end up having 3 as our square root. So basically the square root of this particular expression then becomes x plus b all over 2. All right, x plus b all over 2. So why don't I write a common law in this particular scenario? All right, so I want you to note that for a quadratic expression to qualify as a perfect square, then it must take this format. All right, for a quadratic expression to qualify as a perfect square, then it must take this particular format. And this is a very important note. All right, so this is a note on perfect squares of quadratic expressions, that it must take the form of x plus bx plus, okay, b divided by 2 squared. All right, and this here can always be rewritten in terms of x and b as x, all right, plus, always look at the sign of b there, plus b all over 2, all right, whatever we have here, squared. Then when we have it written like this, then we can easily form the square root, and the square root will always be x plus b all over 2. Why don't we handle example then see how we can apply this knowledge? Thank you. All right, now dealing with our example, we have a problem here where we are supposed to make the expression x squared plus 8x a perfect square. All right, so make this expression a perfect square. So we already know that a perfect square should generally have the form, all right, should generally have the form x squared plus bx plus b all over 2, all right, squared. That is the general form, the general formula of a perfect square when you're talking of quadratic expressions. So if we are going to make x squared plus 8x a perfect square, then it means that we are going to have to identify the value of c here. All right, note that this here is identical to this. Basically, we're having this as our a equals to 1 here, a equals to 1, a equals to 1, and of course this is the variable x. Then in bx we're having 8x, of course, so basically from what you can observe here, the value of b from this format is equal to what? Is equal to 8. Then we basically have to find the value of c to make it a perfect square. So we can tell from the expression that we have here that the value of b is actually equal to what? Is actually equal to 8. So for us to write it as a perfect square, then we're going to have it as x squared, all right, plus 8x, yeah, you remember that's the value of b, 8x, all right, plus, now that we already know b, plus b is equal to what? 8 all over 2 squared. All right, so this basically will simplify to x plus 8x plus 8 divided by 2 equals to 4 squared. All right, and so the final answer will be x squared plus 8x plus 16, and so that basically will be our final answer. All right, so of course we can go ahead and find the square root, okay? But that is not the intent of this particular class. So we are just going to actually let me just do it, all right? So we've already solved the problem, but now as a bonus question, what if you are asked to find the square root of this particular perfect square, all right? What would be the square root of this particular perfect square? All right, so let me just show you how you'd find its square root, okay? Remember, we said that for us to have a perfect square, when you're talking of quadratic expression, it should be in the form x squared plus bx plus b all over 2 squared, okay? Plus b all over 2 squared, all right? And that we can rewrite this using x, and if we rewrite it using x, it will be x, okay, plus b all over 2 squared, all right? So that is how we'd rewrite it using x. So basically that tells us that if we are to find the square root, then it would actually be, okay, x plus b, the square root of x plus b. So the square root of x plus b squared. Note that this will simply be x plus b. b all over 2, sorry. B all over 2. This should be b all over 2 from here. Right, b all over 2. So basically it will be bx plus b all over 2. So for us to find the square root of this expression here, it simply means that it's going to then be, all right, its square root will then be equal to x, all right, plus b all over 2. B all over 2, our b is equal to what? Our b is equal to 8. So 8 divided by 2 will be equal to 4. So it will be x plus 4, all right, and that will just be the square root. Because remember, this is how we find the square root. This is how we find the square root of perfect squares. So basically that will be x plus b all over 2, which is actually 8. So x plus 4 will be the square root of this particular expression. All right, why don't we handle the final example in this and then call it a day? Awesome. So handling our last example. So we are supposed to make the expression p squared minus 6p a perfect square. All right, a perfect square. So we know that the general format for a perfect square should be in this particular case, instead of using x, we'll use p as our variable. Should be p squared, all right, minus okay, where is I'm getting confused lately. Okay, should be p squared minus b minus actually not minus but plus p squared plus bx, okay, plus b all over 2 squared, all right, plus b all over 2 squared. So this is the general format for any perfect perfect square when you're talking of a quadratic expression. It's basically the variable squared plus bx plus b all over 2 or squared. So this basically means that for us to complete this particular expression and write it as a perfect square, we're going to have to find the value of c, all right, which in this case should be b all over 2 squared. And so what is the value of b? So in this particular expression, you can see that the value of b is -6. So we're going to have it as -6 there. Now we're going to write the whole thing in terms of with -6 as the value of b, and then solve the whole problem. So it's going to be bp squared, right, minus 6, all right, 6p plus -6 all over 2, all right, in place of b here, -6, yeah, all over 2, and all of that should be squared. So basically we're going to have p squared minus 6p, all right, plus, now what happens when we simplify that out? Plus negative, that is negative 6 divided by 2 give us negative 3 squared, all right? So our final answer will be p squared minus 6p, all right, plus what? Negative 3 squared happens to be what? To be 9, plus 9. And so this will be this will be our perfect square. We'll have completed this expression p squared minus 6p as a perfect square from this particular scenario. So if, assuming we were also, though this is not part of the equation, we were to find the square root, okay? If we were to find the square root, then how would we handle this? Remember that we can always find the square root, of course, if we have it in the form p squared plus bx. This is the form for all perfect squares when you're talking of quadratic expression, over 2 squared. Then if you were to find its square basically should be p, all right, plus b all over 2 squared. So the square root will be the square of whatever we have on the right side, and that will be so the square root will be, all right, p plus b all over 2, all right, p plus b all over 2. So for us to find the square root in this particular case, then we're going to have it as p plus, we know the value of p as negative 6 all over 2, all right, and this will be p minus 3 as our final answer when you're talking of square root. So the square root will be p minus 3. So I want to commend you for watching the video to the end. This basically is what we call completing square, all right, completing a square of a quadratic expression. And this method can always be used to solve quadratic equations, which we shall do in the next class. See you and have a wonderful time with your studies.